Okay, so can you hear me okay? Okay, great. Okay, so today we continue on the project management, the second topic, project estimation. So uh, yeah, so we're going to discuss the important aspect of the software planning, estimation of the cost and the resource needed. So here, yeah, first let's see what is cost estimation. It is a process of forecasting how much effort, money, and the time a software project will require. So last week we discussed the scheduling. That's basically part of this project estimation. But today we focus on the effort, the money, how much we need to complete a software project. So this estimation is very important in every stage of software development, especially in the planning and the budgeting, to give the project manager and the stakeholder ability to make informed decisions. Think about this: if the estimate is too low, then your team may run out of budget or time midway through the project. So we see that last week we discussed the N-value analysis. That's to keep track on the schedule and the budget. So that's based on the budget already being done. So this estimation is before that. Before we do the budgeting, we need to know how much the cost of the software. And in order to do that, we need a kind of a matrix to help us to do that. If we have a historical data, that'd be great. Then we can compare the historical data and then get insight from the past project, and then we can estimate how much the current project required. And also, when we do that estimation, it's better to have a quantitative prediction instead of a quantitative information. So basically, even though in a very early phase, we don't know much about the project, we still need to give some kind of estimation so that we can do the planning. So then this come to the next estimation, the life cycle. So you may think of this cost estimation as a one-time shot. It is an ongoing process because you can see that at the very beginning, we don't have much information about the project, but as the project move on, we gain more information about the current project. And then with the past project information, when combined two together, we can refine the cost estimation. This will give us an accurate cost. So then is looking at the methodology that we can use. The first one is called we use the past similar project. So we use data from previous similar project, assume that if your current project is similar to the one you have completed before, and the cost and effort should be somehow comparable. For example, if your project team develop a mobile app like cost 50,000 last year, and then you may give a estimation of 75,000 for new app. That's 1.5 more complex. So somehow you can, as long as you have the past information, you can always use this to give you a sense how much the new project will require. And the second approach is using the expert judge. So if we don't have past project, but expert may have experience of the project in other entity in the other institutions, the project, then the expert can give or based on the domain knowledge, can give some estimation. And the third approach is a process-based estimation. Actually, our lab is using this process-based estimation. So we break it down into the individual task. So in order to do that, we have different ways. We can use a top-down. So first we divide it into the framework activities like planning, uh, analysis, and design, coding, and testing. We have like a higher level phases, and then further decompose into the concrete detail, the concrete task. or the bottom-up estimation is to start with individual tasks, and then we group them into category and so on. So it doesn't matter we use top-down or bottom-up estimation, we end up with something like we have in the lab, the Gantt chart. We have the category, and each category has the task, and each task has the duration, and then we know who is responsible to the task. So this process-based estimation is very accurate. So this analogous and expert judgment can only give you like a very brief, very general estimation, but this process-based estimation can give you very accurate because we break down into individual tasks and estimate based on the task level. So as long as we break down into the granularity that is manageable, then we can focus on individual tasks. Is easier to focus on the project as a whole. So this project process-based estimation is what we will practice in the lab, and this is the most accurate estimate. Another approach is using some metrics we call the algorithmic and empirical model. For example, we use the line of code, we use the function point, and in the agile process, we use the stories. We use some kind of metrics, and with some historical data, then we can build this empirical model. And we will spend some time discuss this model. And the machine learning model, machine learning method, this is one we have a lot of data. Then we can learn from the historical data, and this machine learning method will also build this relationship. To use this model, we need to have much historical data to do that. So basically, these are five approaches. Let's start with the judgment. So the expert judgment. So this is one we don't have much information. So here, this expert judgment is one of the most commonly used method in project cost estimation, because this one is don't need much information and it's fast and informal, and the practice knowledge of experienced individuals can help. So when you especially when you're pressed for time and need a quick estimate, and then consulting with a senior developer or project manager who have handled similar project before, and they will give you the estimate. Yeah, of course, using this approach have some challenges. First, this method is highly subjective, and the two experts may provide a very different estimate based on their experience and personal bias. So it may lack consistencies. So in order to uh, to like to make these differences less less problematic, we can use this let each expert to give their most pessimistic estimate, most likely, and the most optimistic estimate. Then we can use some formula to have this expected value of estimate. And then another approach called the Delphi technique. So here, and this one is structured group estimation technique, and they involve gathering input from a group of experts, and they will make a secret guess with rationale. So, and usually we do this through the survey or questionnaire. And in the first round, each expert submit their estimate independently. And then the facilitator will compile the result and then share the summary. Usually the average, the range, the median, and the reasoning. So some data to share with the group. Then the expert revise the estimation based on the shared feedback. And this process repeat for some round until the estimate converge. So in this method, the process, then we can avoid conflict among the experts, and also we try to avoid someone dominate the discussion. So this is the using the expert judge based method. The next one is a process-based, as I mentioned, the two approach, top-down and bottom-up, and whatever approach we take, and eventually we have this Gantt chart. That's what your lab 2 is going to do. So we're going to spend some time here today when we discuss the lab. Okay, so the next is using the empirical model. We empirical model involve using some metrics like a line of code. The AOC stands for line of code or function point. This one is a traditional metrics for estimation software size and the cost. And this one involve predicting the number of line of your team and so yeah, for example, if your developer is going to average 50 line of code per hour, then the system is expected to be like a 10,000 line and so on. So these days, because these AI tools can generate a line of code, can generate the code, so this approach become kind of like obsolete. But still, we can use this one as a benchmark. We can use this one as a benchmark as long as you have historical data. If your historical data using AI and your new project also use AI, then you still can use this line of code or function point approach. And then, so here, for example, like for each function, we give the estimate line of code. And then if you have historical data, for example, like in the past project, a similar project, and the productivity of the team is about 620 line of code per PM. PM is person months. Is a person, so which means a person take 1 month to develop 620 line of code. You may wonder why it's so low. Actually, remember last week when we discussed how we schedule the project, it's only 15 and 20% of time we used it, I mean, spend on developing code, and the majority of time is like the requirement and the design and the detailed design and testing and regression testing. So basically, this line of code is spread out the entire project, and then you have so many people working together, not everyone writing code. So this productivity is the overall productivity of the entire team. So that's why it looks very low. I mean, the first impression is, yeah, it's very low, but when you put it into the context, you understand that. So this past data shows this is the productivity, and then your labor rate. So here is like 8,000 per month per person. So this average you pay 8,000 for an engineer to do the job. So here you can calculate the line of code. The cost per line of code is $13, and then if your total line of code is 33,200, then you can estimate the cost is 431,000. And the total effort, then you can also see like how many people you need. If 33,200 divided by the productivities, then you're going to need 54 person months. So this means if you want to complete the project in 1 month, you're going to need 54 people. And if your project is 2 months, then you may just need 27 people. So here give you like a rough idea how many people you need and how much the cost, and then you can do the planning accordingly. So these are problem based on the line of code. So similarly, since the line of code is especially now you're using the AI and is a traditional way, so it's not quite convincing. Another approach is using the function point, and in the agile process we can use the story-based estimation. So here the function point is not based on the code anymore. It's based on the functionality provided by the software, and then then we calculate the function point, and then once we calculate the function point and your historical project also calculate function point. Then we can use function point as a line of code here. So here you can also have like the productivity of function point per person month, and then the labor rate is 8,000. Then you can see like the cost per function point is how much, and then you can do, the same approach. So here, since this function point is not very popular now, so I'm going to skip this part. So basically, once you have this function point, you can use the same way as line of code. So this approach are similar. It's just using different metrics. Now we are going to go back to your lab, the second part. Okay. So here is what we have. We have this Gantt chart. So here I want your lab one. Your first part is to make make 3 months. You'll make 3 months, and I hope you already completed. And then this week assignment is more complicated because you're going to assign each task to the individual team or individuals. So here's involve like how many people do we need, and how many people I should assign, and so on. So this is quite so here we actually using the process base. So here I assume that in your task in your lab one, you already have this concrete task. In this week, what you're going to do is for each task, you look into the task to see how many people I need. Okay, so here first let's looking at go to the resource the resource sheet. So here we have only 8 people. So here come to the question, how many people we need for this project? Okay, uh, let me bring the allocation here. Let me bring the allocation here. So remember our total budget I already gave you is $1 million. Remember, is $1 million for 3 months. 3 months. So this, if you like for 1 month, how much you need? So basically, for 1 month, you're going to spend 333K per month. Okay, suppose that's the case, you're going to spend 333K per month, and we assume that the cost is all associated with the engineer. So hardware and this clouding and the cloud service cost, we don't consider that part. We only consider this $1 million is for salary only. If that's our assumption, then we are calculating how many people we need. So if based on the current rate, if each engineer, I mean, their average cost is 10K, is 10K per person per month, So this is about, so here the rate is, so their rate is by hour, and here is by month. So here we can see that what's the hourly rate? If 10K per month and 1 month has 4 weeks, and each week has 40 hours. So a month should have uh, 160 hours. 160 hours. So 10K divided by 160, you can do a quick calculation. That should be around 60.5 per hour. So which means if everybody in here, sorry, if everybody in here you put their standard rate as 62, as a 62.5, then this means you paid this person, about 10K, 10K a month, 10K a month. If that's the case, how many people you need? 10K a month and it's 33.3K a month total. So if this is the case, you're going to need 33 software engineers. So which means if everybody you pay, I'm sorry, if everybody you pay 62.5, 62.5, if that's the rate, you're going to need 33 people. So here there's only 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only 9 people. That's not enough. You need to add more people in here. You need to add up to 33 if the average rate is 62.5. So then you may say, okay, I'm going to pay them more. So if you pay them more, if it's not 62, for example, let me make it. If you're going to pay them like $80, 80 average hour, and that's also very reasonable. I mean, nowadays, uh, dollar, and then this, so this is, let me see, this should be the 112,800 per person a month. If that's the case, you're going to 333K divided by 12,800, and that's about 26 software engineers. So you can see that based on your hourly rate. So here, if everybody is about, yeah, if everybody is about, I mean, if your average is 80, yeah, so you don't have to be like all 80. Someone can be 100, and somebody can be like 60. But if the average is 80, then you're going to need 26 people. So no matter what, you're going to add more people in here. The original, I mean, the original this team is not enough. Because so for example, here you can have like a developer one, or you can have like a developer John. You can, yeah, you can give a name and so on. So here, you add more people in here up to 26 if your average is $80. So you add these people in here, and then okay, let me make them 180, 160. Okay, so here you add more people up to like a 26 to 33, and based on how much your hourly rate, you should have an estimate how many people you need. So that's the first to decide how many people you need. Then, okay, let me clear this. Oh, okay. I'm going to clear or join. Okay, clear or join. Okay. Now, you add 26 to 33 people in here. Next, we go back to the Gantt chart. We go back to the Gantt chart. Here, we need to add people to each task. So there's a trick in here. Originally, the task is assigned to one individual, But in order to use all these people, uh, in order to make them all working full time, you cannot just assign to one person. You need to assign to multiple person. For example, in here, I can assign to the developer one as well. So here you can check how many people you want to involve in this task. So you can see that this task is taking 4 hours to complete for one person. If you choose 4 people here, and this will change this duration automatically to 1 people. So that's something you don't want to. You see here it now become one. So you want to go, so you need to memorize what is original duration, then you change it back to the original duration. Otherwise, if you assign to multiple people and duration goes shrink, and then your originally is 3 months, and then you see that you're going to take less than 3 months. So basically, you screw your first part of the assignment. So you want to keep your first part assignment intact by adding only more people involved in each task, while keep this duration the same. So in this case, you can assign more people to the task, then your cost is going to increase. So in here, you can see you can always you go to the view. Let me see. There should be a cost view. Okay, other view, more view. Okay, that's okay. Let's go to the report. Let's go to the report. Oh, here. Go to the cost. Uh, yeah, the task cost overview. Okay, now you can see that. Uh, now my cost is 125,000. So in order to make $1 million, I need to, for each task, I need to assign to more people and at the same time keep. So here, for example, is analysis. So here I can, you remember these 5 days, and then you give to 5 people, for example, give to 5 people, and then keep this one still the 5 days. Still 5 days. Now you can see the cost going up. Okay, so this is one way to do that is to add in more people in here. However, you need to pay attention that since some of the tasks go in parallel, some of the tasks go in parallel. If you assign one person into multiple tasks at the same time, then you're going to overuse that person. That's something I want you to avoid. So here, for example, I still go to this resource sheet. You can see that those people, they're highlighted in red. Why they're highlighted is because they are being overloaded somewhere in here. Somewhere the developer, test, and trainer and this technical communicator, they are assigned to multiple tasks at the same time in certain day. So that's why they're overused. So I want you, when you do the planning, when you do this here, you assign them to a task and make sure you are not overuse, not overuse them. Okay. So that's yeah. So that's the task two the, of your lab. So this one involve like a few things, as I mentioned. You need to first add more people in here based on their rate. And secondly, you need to, and you're going to mainly spend time in this Gantt chart, assign to multiple people, and at the same time not overuse them. So you need to, go to individual tasks one by one, and then make this $1 million. Okay. So any questions so far? And I see that's should we hold our question about project at the end of class? Okay, yeah. So basically, that's the lecture part of today. So you can ask me any question regarding the labs.
Yeah, I have a question.
Okay, go ahead.
Yeah, so on the lab 1 and 2 instructions, there's a bullet point that I'm not really understanding what to do with it. It's just not, I don't understand it. It says generate 4 to 5 reports. One of them must contain the total costs. What are we supposed to do with this one?
Okay.
What's Yeah.
Let me pull up the lab assignment document. Okay, so you are referring to generate report, right?
That's
Okay.
correct.
Okay. So you can see that if you go to the project, there is a report on the top. There's a report. So there's a lot of report you can generate. And here, I don't care what project you generate, but one of them should be like, for example, here shows that uh, sh- shows how much the cost in total. So this is so here you can go to the report and go to the cost, for example, like the task cost overview. So this one will show the overall cost. Okay, then you can generate some other report as well. So you can play around with the report. So because there's a lot of report you can play around, and I don't specify which one, but one of them is this. As I mentioned, is a task cost overview. Okay, does that answer your question?
Yes, and maybe just one more question about it. So when we generate report, it can be anything, maybe like the maximum members, or I mean, one of the examples you mentioned is like the payments we're paying to the each member, maybe like of each month.
Yeah, of course. Yeah. So
Yeah.
you can use any available reporting here. So there's a way more than you can use than five. Okay. And also you can customize your report. So just as long as the report is included in here, you feel free to use.
Okay, thank you.
Okay.
And another question about this one. So there's one where it says explore the following views, provide screenshot of each and describe its applicability. So when we screenshot it, do we describe like what do we see? Like for example, for the resource sheet, we see like each member's material, initials, etc. Is this how you want us to describe it, or do you want us to go like deeper explanation?
Okay. So here is the resource view, right? So when you do the screenshot, you can just print the screen and just screenshot this part. Okay, you just screenshot this part and put this one in your report. And then once you provide when provide a screenshot, then you must know what this is about, right? So provide some description of this resource. For example, this resource view is give us like how many people we have and what's their payment rate and so on. So you just give some description of telling this what is the view about, what this report is about. Okay, a short description is enough.
Okay, so can I say like this resource sheet, like for example, this resource sheet has resource members with the payments that we're providing for each member an hour? Would be
That's
something
right.
like,
Yeah, yeah, yeah. Basically, that's it. And also this one highlight anyone who have been overloaded. Yeah, you can mention that.
okay, thank you.
You're welcome. Uh, any more question from student online?
I had a
I
quick
actually
question.
wanted. Oh, sorry.
Oh, you can go first.
I was just gonna ask for the generated reports.
Okay.
How exactly would we include them? Would we print or not print, but like
No, you don't print. Yeah, yeah. For example, let me open a new Word document. Okay, for example here, and then you can just so let's go to one report and go to the resource. For example, like a resource overview. Okay, I have this resource overview, and then you can just provide a screenshot. You don't have to print. Okay, you don't have.
oh, okay. So we just screenshot it and include it in the
Yeah,
Word file.
yeah, screenshot is one, and then Then open this Word document and just you paste in here, and then you provide some description, okay, of this report.
Okay.
Okay. Yeah, I hear there's some other student has question.
Yeah, so you, just to be clear, you didn't want any specific number of new resource people added to the project. We just add some number and set the appropriate recording salaries.
That's right. Yeah.
Okay.
Yeah. So how many people you need based on their salary? Yeah, based on their salary. And also another factor is are they are they working full time? You know, sometimes if the task are so yeah, for example, like if there's a task in parallel, you may overuse some of them, and some of them may not be fully used. So if in that case, if someone is working part-time, so someone is working part-time means for a certain day and a certain time, this guy has no assignment. If that's the case, you're going to need more people. Yeah, you're gonna need more people. So you play around. So here is a number one, you have enough people. Number two, make sure they all working every day they have assignment. And the third thing is make sure every day they have assignment, but they don't use they're not working in parallel in more than one task. So yeah, so here you need to massage and refine this planning.
Okay, thank you.
Any more questions from students? Okay, so if there's no more questions, then you have 2 more days to complete the lab. So please complete it on time. This lab has 8 points. It's quite significant. Okay. So and also this is the first task. I want you to have a good start of the semester. Okay. Then I will see you. Oh, there's no let me see. Based on the schedule. So the next week, we don't have a meeting next week because it is Memorial. Oh yeah, the week for the next week, the Memorial Day, there's no class, then we have no lab. So I will meet you in June. June 2nd, we work with the configuration management. Okay, I will see you in 2 weeks, and have a good week, and a good Memorial Day weekend. See you.
Professor,
Yes.
so I want to ask about the project. So once when we're finished with it, will we look back at it? Like, are we gonna use it for the upcoming labs, or for the upcoming labs we'll be looking at different applications?
Oh, you mean the 10 project?
Uh, yeah, like the project that we're doing on lab 1 and 2.
Oh, the level 1 and 2. Let me open it.
Yeah. Because what I'm doing is I'm trying to make sure it's all like kind of makes sense. I'm providing each member like a right salary and not just like putting a random number. Because what I'm thinking and I'm a little bit afraid of is what if we're trying to use this project again for the upcoming weeks? Will we see it again? Because I don't want to revise and redo everything.
Yeah, once we complete the lab 1 and 2, we do not look back. So your future assignment has nothing to do with this part anymore. So this is just a one-time planning.
Okay, thank you.
Yeah, you're welcome. Okay, so I will see you in 2 weeks. And bye.
Have a good day.
Okay.
Bye bye.
Bye.